Okay, so far in Chapter 9 we've talked about adding and subtracting, and we've talked about multiplying. Let's see how we're doing with all of it. Number 1, what'd you get? 4 competent people. 7 competent people. Start with Sharif, Tristan, Hezekiah. What'd you get?
Number 1, 2a squared plus 14.5a plus 15.
Okay.
2a squared plus 14.5a plus 15.
Okay, so I think that was the same thing you just said in decimal form, Hezekiah.
2a squared plus 14.5a plus 15.
2a squared plus 14.5a plus 15. I don't care if the 14.5 is in fraction or decimal form, it doesn't matter. Number 2, what did you get? We'll start with Alicia, then go to Zabari, and then Brian.
X squared minus 16.
Okay? All 3 of you agree it's x squared minus 16, and that is correct. Number 3, what did you get? Catalina, Kamoy, and then Brandon.
4b squared minus 9.
All 3 of you agree it's 4b squared minus 9. What about an expression for the volume of this box? We'll start with Jada, then we'll go to back to Sharik, and then we'll go to Maria. Okay.
What she said.
What did she say?
18x squared plus 30x plus 12.
Okay, Maria.
18x squared plus 30x.
Very good. All right, comments, questions, and concerns, anything at all? Hezekiah, will start with you.
I got like 18x squared and 7 plus 12.
Okay, well, let's take a moment and explore number 4. Give me a thumbs up if you got number 4 correct. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, put your thumbs down. So that's about half my class. So I've got a lot of people in the room who need to learn from their mistake. Okay? So Dayanara, what did you attempt to do for number 4? Good. So what did you write?
I kind of did the first two.
Okay. Well, okay, good. So what was the second one that you did in your head, but I'll write it out? Oh, okay. So you did 6 times x plus 1, and you did it in your head right away. And then you multiplied it by the, whatever we want to call this, the width, 3x plus 2, and you already caught your mistake that you distributed incorrectly here. Very good. Outstanding. So give me a thumbs up if that's what you wrote out. Anyone in the room who wrote that out. Okay, Sebastian, what did you write?
I wrote 6 times area of x plus 1 times area of 3x plus 1.
Okay, so that's that. So when I said give me a thumbs up if that's what you wrote, then you didn't give a thumbs up. That's why I called back on you. Okay, so I'm trying to see. So did you end up with the correct answer, Sebastian? Oh, okay, good. So the question is, how do we get from here to here? A lot of my students get confused. I don't know if they're in this room right now, but in past history, some of my students think that they're supposed to go like this. And that's where a lot of people get confused. So here's what I propose as a way of gaining perspective. So let me present an alternate problem, a very simple one. Let's do 5 times 3 times 2. How do I multiply 5 times 3 times 2? Literally, how do I do it? Anita? Very good. So we do not do this. You don't do 5 times 3 is 15, 5 times 2 get 10, and then add them together. That's not what you do. You multiply the 5 times the 3, and then the result. That's what Aeneas pointed out. Then the result times 2. And that's what Dayanara was demonstrating that she actually did it mentally, is that she multiplied this first, got the result of 6x plus 6, and then multiplied that times 3x plus 2. As she said, she made a mistake right there and got it wrong, but she had the right idea. Okay? Any comments, questions, concerns on any of this? Come on. Bless you. Okay, so you got, did you get like 3x squared plus 5x plus 2? Okay. Good. All right. Any other comments or questions? Good. Now I have a question. Does anyone notice anything unusual from numbers 1 through 3? Anything unusual that happened over there? I got 5, 6, 7, 8 people. Alicia and then Maria. Alicia, what did you notice?
Like, when I did the twos and 2 and 3, when I did it, like, 2 of them would cancel each other.
Okay, Maria. Okay, so we can FOIL all of these, right? They're all binomial times binomial, so FOIL all of them. Okay, that's absolutely right. But then you just, let's go back to what Alicia said, because what she said is important, but Alicia then noticed something that we never saw before. And what was it again? You said for number 2 and 3?
Cancel each other.
What did?
Negative 4x and 4x and number 2, and then number 3, 6b and negative 6b.
Okay, very interesting observation. And look at what the result looks like. Anyone notice anything else? Eric?
You can just multiply the, for number 3 and 3. You can just multiply, for number 3, you can just multiply 2b and 2b and negative 3 and negative 3.
Okay, well I see a negative 3, but I don't see another one.
Negative 3 and 3.
Okay, so you're saying we can just multiply that, and we end up with the answer, which kind of reflects what she said, which is that the middle 2 terms cancel each other out. Catalina and then Brian?
If you just say like the same numbers but a different symbol, you already know that it's going to cancel each other out.
What do you mean the same numbers in different symbol?
Like, let's say number 2, it's x plus 4, and then the other one is x minus 4. They're the same numbers but a different way to work them.
Okay, so if I can modify what you're saying just a tiny bit, she's saying that it's the same expression, except one has a plus in between and one has a minus in between. And then she's now connecting that to Alicia's observation. Okay, Brian?
I was gonna say that the answer from number 23 is squared of the root of, for example, 2x squared minus 16 is squared from x plus 4. But then I caught myself because 4 times 4 is negative 16, so you need to split the sign.
Okay. Very important observation. Very good. Okay, so keep these things going in your mind because something's going on there that you need to start exploring. Okay? That's what this level of class is about. Looking at patterns, seeing something that comes up that you never was introduced before. Will that pattern continue? Will that happen in every case? So we'll see. Any other comments, questions? Good, we're doing very Today, we're going to explore some special cases related to what we've studied already. And you've actually already seen them. I did today's warm-up on purpose. And so I was trying to tease out from you your observations about numbers 2 and 3. So Maria pointed out when we started exploring this for a few minutes that for numbers 1, 2, and 3, you could FOIL it because they were all binomial times binomial. But then Alicia pointed out something very interesting that happened in numbers 2 and 3. That the two middle terms canceled each other out. And then we went even further, and Catalina pointed out that it's the same expression twice, except that the operation symbol in between are opposite. And so when you put these pieces of information together, what happens is you actually end up with a pattern. And the pattern is true every time. So this is one of the new ideas you're going to explore today, and it's called the sum and difference pattern. And so I think Eric and Catalina and Brian were trying to articulate, again, when we were discussing this during the warm-up, they were trying to articulate the shortcut that they were discovering. And so here I am showing you a generic model of it. When you have a case of the same expression multiplied times each other, they're both binomial, and the only difference is that the symbol in between is opposite, you actually end up with the square of the first term, that's this, the square of the second term, that's this, with a subtraction sign in between. Every time. So here is a practical example. 3x plus 4 times 3x minus 4. Square the first term. So we square the 3x, you get 9x squared. Square the second term, you get a 16. Put a subtraction sign between. This is called a sum and difference pattern. Now, we have more. There's going to be another couple of patterns that we're going to explore, but I want to pause here to emphasize the incredible importance of you knowing this instantly. Now, you're just being introduced to it, so I don't expect you to know it instantly right at the moment. But by the end of the homework assignment, the idea should be so clear to you that I could give you any situation that's similar to this, and you should instantly, within 2 seconds, be able to tell me the result. That's how well you need to know these shortcuts. And I cannot overstate the importance. In about 3 lessons, I think it's 3, about 3 lessons from now, we're going to be going backwards. So you have to know this so well that when I show you how to do it backwards, that it's still instant for you. So that's really the idea here, is to get it, to be able to do it, and to be able to do it really quickly. Before we get to that point, I want to show you why it works. And Alicia already told us, but I want you to see it. So we're going to FOIL this out. You should already know exactly what's going to happen. You take the first terms. 3x times 3x, we get 9x squared. Do the outer. The outer is 3x times negative 4, we get negative 12x. Do the inner. 4 times 3x, we get positive 12x. And then do the last terms. 4 times negative 4, we get negative 16. One of the benefits of FOIL is that the 2 middle terms are the like terms. So that was one nice thing that we learned last time, was that and that will always be like terms when you do FOIL. But in this case, now you see what Alicia pointed out, which is that the 2 middle terms are opposites and they disappear. Brandon.
Does that the pattern and the photo method work with no numbers having
You have to show me an example of what you're referring to, and then we can explore it. Let's come up with an example. I want you to write it down right now. And then when we get towards the end, I want you to bring it back up so we can explore it as possibly a special case, okay?
Is there a scenario where it's going to be like in the first part, it's going to be like negative 3x plus 4 times 3x plus 4?
Well, that's a good question. And I'm going to show you. Can you write that down for me just on the side of your paper? And I want you to bring it back up at the end so I can show you what really happens there. Okay? Good. So that's the first pattern. There's actually another pattern. And you do have to know the names of these patterns. You have to be able to speak to each other and to me, telling me what the pattern is so we know we're talking about the same thing. So that's the sum and difference pattern. There's another one called the square of a binomial pattern. And we call it a pattern because you discover it by looking for the pattern that's happening over and over again. If we have a similar case, but instead of it being the same expression but with opposite operation symbols, what if we have the exact same expression times itself? Well, that's actually a pattern as well. There's two versions, but it's really the same thing. Here's what will happen, and you're going to see it happen. We're going to do this together. But if you have an expression times itself, the result will always be the square of the first term, the square of the last term, and then there's a middle term. They don't cancel each other out, but what happens is it's the same term twice. So you do A times B, and because there's two of them, you multiply times 2. Don't worry, I'm going to show you this and you'll understand. And then there's another version. The only difference is that there's a subtraction symbol between this one, and this one's an addition symbol. And the difference here, the result has a subtraction symbol in this position, this one has the addition symbol. So let's look at some practical examples, and we're going to do it the long way to see what happens, and then hopefully we'll see why the pattern works. So don't worry about this on the right, let's just worry about this. So if we have x plus 4 squared, that really means x plus 4 times x plus 4. Let's FOIL it. Okay, I'm going to go super fast. You guys don't need me to go slow. I'm going to go super fast. X times x is x squared. The outer, x times 4 is 4x. The inner, 4 times x is 4x. And the last terms, 4 times 4 is positive 16. In this case, instead of the two middle terms canceling each other out because they're opposite, the two middle terms are identical. So what's 4x plus 4x? Ania? 8x. Another way to get that, this will be 8x. Another way to get that is by taking the 4x and multiplying it times 2. 2 times 4x is also 8x. And that is why there's a 2 here, because this pattern happens every time. What we're saying is, look, this is really that times that, and then there's 2 of them, so do that times 2, and that will give you the middle term. This is a shortcut. This is an incredibly efficient shortcut. Any questions about that? All right, let's see what happens when there's a subtraction symbol with the binomial. this really means two x minus 6 times 2x minus 6. FOIL it. 2x times 2x, 4x squared. 2x times negative 6 is negative 12x. Negative 6 times 2x is negative 12x. Negative 6 times negative 6 is positive 36. The pattern works every time. We end up with the same term twice. 2 times negative 6 is negative 12. Times 2, because there's 2 of them, and that's why we get the negative 24x. Does anyone have any comments, questions, or concerns? All right, let's put it into practice. Example 1. I mean, the examples are kind of silly during this lesson because we're not going to really be exploring a process. We're actually trying to explore how to skip the process. So usually my examples have lots of work and lots of things to explore, and this is the opposite. We just want the answer and we want it really fast. So give me a thumbs up if you already know what the result will be for part A. Okay, some of you. Good. And what do you think it's going to be? Good. Yep. This is a sum and difference pattern. This is the one where the middle terms disappear. So there's no middle term, and so all you have to do is square the first term, 81w squared, square the second term, 9, and put a subtraction sign between them. And that's it. And we want to be efficient. We want to be quick. Yes?
So basically it's FOIL except without the O and the I.
Exactly. Exactly. Part B. Any questions on part A? Part B. So, no different. Just have to pay attention to details, that's all. Square the first term. What's 1/3 squared? 1/3 squared. 3 hesitant hands and 4 confident hands. Jada? It's not 1/6. This is something that we got to be super fast at. Zubari? 1/9. Remember, multiplying fractions, you multiply straight across. So 1/3 n squared would be 1/9 n squared. What about 6s? What will that be squared? Catalina?
Oh, S.
Negative 36, but now we're squaring the s. So it's s squared. Very good. And that's it. This is a sum and difference pattern, so there will be no middle term. It disappears. And that is it.
For any polynomial that has two terms or more that have the same degree, would you put it in order of
Well, you mean like how do I know which to put first? I'm not sure what the teacher for Algebra 2 would say in a case like this, because they're both the same degree, like you said. I think you put it in alphabetical order, but I'm honestly not sure. I'll look it up for you. Okay? There might not be a rule for that. Any other comments, questions? Okay, so I'm going to do something differently than what I normally do. I'm actually going to set up my clock for the checkpoint here, because I don't want you to see the question. And you're going to only have 30 seconds to do both of them.
That's
You can start to go to the next one.
So I'm going to start the clock, and then I'm going to show you the questions. And the point is, I don't expect you to be perfect at it yet, but you should be on your way to being able to do this pretty quickly. So, here we go. Here you go.
That's not even 30.
Still talking.
That's not fair. She was 10 more seconds. You couldn't give it away in 10 seconds.
All right. So, most of you were busy, but all right. So, speed is great unless you get it wrong, and then of course that was a total waste of time. So let's make sure that we're doing it efficiently, quickly, and getting it right. We'll start with Alyssa, Tristan, and then Kayla. What did you get for part A?
16d squared minus 36.
What do you think? It is 16d squared minus 36. What about part B? What'd you get? Got Catalina, Kamoy, and then Alia. Okay.
144 minus x squared.
So they all agree, and that's correct. Now, technically, the f squared is supposed to come first. However, in these cases where the 12 came first in the binomial, it's perfectly okay to put the result in that order as well. That's why I did put it in that order. But if you wanted to put negative f squared plus 144, that's the same thing. Okay? Any comments or questions? Okay, give me a thumbs up if you got both of them right. Good, put your thumbs down, almost 100%. Very good. So now let's explore the second pattern, which does take a little bit more effort, and there is a danger zone that you need to be aware of, but still the same basic idea. Trying to skip over work to efficiently and quickly get a simplified expression. So the first pattern was called the sum and difference pattern. This one's called the square of a binomial, which makes perfect sense because there's a binomial and it's squared. This is the case where instead of the middle terms canceling each other out, the middle terms are identical, and so you end up doubling the middle term. So here's how it goes. Take the first term and square it. So it's going to be 7y squared. Take the last term and square it. So it's not going to really make a difference. You could do negative 3 squared or 3 squared. You still get the same result. But then we have a middle term. And the middle term will be the first term times the last term times 2. So it'll be 7y times the negative 3. I didn't leave myself enough room, so let me fix this. Times 2. That's the middle term, and then all the terms are being added. So the first and the last is the same thing you just did. So 7y squared is 49y squared. That's easy. Negative 3 squared is 9. It's now the middle term that you have to be very careful about. So this times this is negative 21, times 2 is negative 42, so it's negative 42y. The biggest issue I have is students forgetting the 2. Someone in this room today is going to do it. Someone's going to do it tonight in their homework. Someone's going to do it next week. Someone's going to do it during the quiz. Someone's going to do it during the test. You're going to do it. But the idea is to make sure that by the time May comes around and we're taking EOC, that it's so ingrained in your brain that you will never ever forget it ever again. Okay? So the danger zone is the 2. Cannot forget it. Any comments or questions on how we did part A? Comments or questions on part A? Okay, part B doesn't look the same, but if you just pay attention, it's the same thing. It doesn't say squared, but it's the same expression times itself, so that's a binomial squared. Square the first term, 64k squared. Square the second term, j squared. Multiply the 2 terms together and multiply that result times 2. 8kj times 2 is 16kj. So what I just modeled there was the thought process that's supposed to happen in your head quickly. I took about 10 to 20 seconds to do it. By the time you're done with your homework, it should happen so quickly, we're talking like a second. Okay? Comments, questions, concerns? Comments, questions, concerns? Okay, this takes a little bit more effort, so I'll put a little bit more time on the clock. Let's say 50 seconds. Let's take 50 seconds for 2 questions, 25 seconds each.
Oh, that was the question.
Give me a thumbs up if you've answered both questions. Okay, well, I am actually going to cut off the time, even though part of me would like to extend it, but honestly, we can sum up the issue in one word. What's the one word that will sum up the issue that some of my students... Confused? Confused? That would be a way to sum up the issue, but it's really a fraction. So there's actually no algebra issue. This is algebra class. There's no algebra issue. There's a computation issue that needed to be taken care of last year. So more than half the class was done, so let's go ahead and get the solution or the simplified expression. What do we get for part A? We'll start with Kezekiah, Sharik, and then Brian.
B squared minus 1 and 1/3 minus 2/3 squared.
Okay?
I got b squared minus 1 and 1/3 b plus 4 9s.
Okay?
We got b squared minus 1 1/3 b plus 2.
Okay? So we have quite a bit of a disagreement. It comes out to b squared minus 4/3 b, which is the same thing as 1 and 1/3, plus 4 9ths. And what about part B? Part B, what'd you get? Spent all our energy on part A and no one can do part B? That's too bad. Maybe you should have done part B first. Start with Sebastian, Zabari, and then Brandon. Sebastian, what'd you get?
16x squared plus 176x plus
Okay.
64x squared plus 76x plus 23.
Okay. Why? Okay, well, just go ahead and tell us. Okay. So what we were looking for was 121 plus 176x plus 64x squared. So what I heard from my students who were brave enough to volunteer was that you were squaring some things and you didn't square other things. Like Zabara, you said 22.
Yeah, I know.
Yeah, you multiplied times 2 instead of squaring it. So you square the first term, 11 squared is 121. Square the last term, that should have been easy. Then the middle term. The only thing that causes issues is the middle term. Multiply these two together, and then multiply that times 2, and that's how you get the middle term. Now, we could spend a bunch of time on part A, but the only issue is fraction. So, got to be able to deal with fractions. 2/3 squared is 4/9. Not a big deal. Alicia, Kamoy, and then we're moving on.
I probably might have maybe gotten it right, but I forgot to multiply it by 2, so I just stopped and
Okay. But I did point out a few minutes ago that people were going to do that today, and the idea is that's okay, but now moving forward, you have to watch out for that. That's pretty much the biggest danger zone here. The only one you have to look out for. Come on.
For part A, I didn't finish it. And the problem with the fractions, I didn't know the B, so I put 6 minus 2.
Okay. And, all right, well, I mean, honestly, maybe I guess I would have thought that your instincts would have said, something seems a little weird with this question.
You put me under pressure. You give me 50 seconds.
Yeah, it's amazing how pressure totally affects how you can do. Jada. Which one? Okay. Well, was it because you fell prey to the pressure because I put such a tight time limit? Or, okay. So let's see how you do on the classwork when we get to it. If you're still not understanding, then we can address it then. We do have one more question, the real world application. So I'm going to put up the real world application. You have to read the situation, and then there's a diagram. You need to write out the diagram, but you do not have to copy the scenario. So go ahead and start.
This is not science. I love those. Hey, that's wrong. Big B.
Okay, so what I actually said was you have to read it and then draw out the diagram. I appreciate the enthusiastic response, but now let's get to work.
So much fun.
All right, so you've already explored this in science class, and I'll be honest with you, this is the first year that I've actually had it work out where my students had it in science before they got it with me. So I'm thrilled because this will work out really nicely. So you should already be familiar with this idea. And it's okay if you were not great at it when you were introduced to it in science, that's okay. I'm going to be offering you a related perspective with some slight differences. So the specific situation here is that we have a mother and a father who are going to have a child. And we have the two genes for eye color, the two that are most commonly explored is brown eyes and blue eyes. So what does the capital B mean when you talk about genes? What does the capital B mean? Shelby? Good. And what does the lowercase letter mean, Maria? The recessive trait. And so, how does it work? Like, how does the dominant trait show up, and how does the recessive trait show up? Like, what has to happen? Brandon?
The dominant trait should show up. It can be one down. It can be one with capital letter, capital letter. But for the recessive trait to be seen, it has to be two.
Okay. Give me a thumbs up if you agree with his explanation. Okay, everyone's agreeing to the explanation? Okay, yeah, I think that's pretty good. So we already have a Punnett square figured out for us. But let's explore this in the context of polynomials. So, first, let's write a polynomial that models this. Now, there is no way that I could just say, okay, go ahead and give it a shot, and you would have any idea what to do. And I'll be honest with you, the first time I read these types of problems, I didn't know what to do either. I had to kind of do a little research. So here's the idea. We want to say that the mother is 50% big B and 50% little b. So we write 50%, but if I want to write an algebraic expression, we don't write a percent symbol with an algebraic expression. What do we write instead so that it's something that we can actually use? Kayla? So what is the decimal form? Very good. We actually write it in decimal form. So what we say is that the mother is 0.5 big B. And the mother is 0.5 little b. And when you add those two together, that's the mother. And the father, in this case, is actually the exact same setup. The father is 50% dominant, 50% recessive, and when you add them together, that's the father. So we're going to write a polynomial that models the possible combinations. So what does this table really represent? It represents something that you might have used when you were in elementary school. Sharif?
It represents the possible combination that a team will occur.
Good. And how did we get all those combinations?
We went along and then, like, lost those. For example, we have big B and big B. We put them together like squares.
Okay, big B, and we got big B, big B. Now in the world of math, how would we say that that actually happened?
We add them up.
Well, what does it mean when you have a letter right next to a letter?
Oh, like we multiply them.
Yeah, this table is a big multiplication table. We're multiplying this times this times that, this times this, and this times that. And then we write each product down in the right spot. And that's how we actually organize information. In fact, did anyone read this section before you came in like you were supposed to? This doesn't. So, this was in the book. This is actually how the book teaches how to do FOIL. I'm sorry, the previous section. The previous section. This is how the book teaches you how to do FOIL. This is FOIL. These are the first terms. These are the outer. These are the inner. These are the last terms. That's a tabled version of FOIL. So, but now look at this. We have actually ended up with the same expression here and here. So which case from today do we now have? Which case from today do we now have? Zabari? Well,
Square of a binomial pattern.
yeah, it's square of a binomial pattern. Okay, so we have square of a binomial. We have 0.5 big B plus 0.5 little, excuse me, I forgot B, little b squared. And so we can now write a polynomial that illustrates that. Because we now have a shortcut to use. Square the first term. What do we get when we do 0.5 squared? Sebastian? We get 0.25 big B squared. Square the second term. What will we end up with? Kayla? Very good. 0.25 little b squared. But the square of the binomial pattern has the middle term. So now we have to multiply this times 2. What will we get as a result of that? Right? 0.5 big B little b. And so now we have written out a polynomial, a mathematical expression, to represent the Punnett square that you studied in science. Does anyone have any questions on how we went about this process? No. Multiply this times this, then times 2. 0.5 times 0.5 is 0.25, but then times 2 actually gets you back to 0.5. Okay? Now part B. What percent of the possible gene combinations results in a child with blue eyes? What do you think, Anissa? What did you think, Shelby? Okay, Tristan, what did you think? Yeah, it's 25%. Where is it represented in part A? Five people caught it? 6 people? Hezekiah?
The last term?
That was all you had to say. The last term right here is saying 25% will be lowercase b, and so that's where we see the 25%. So look, here's double capital B, it comes out 25% of the time, 25% of the time. This is big B, little b, big B, little b. It happens 2 times out of 4, that's 50%, there's 50%. Okay? Comments, questions, concerns on this little exploration we did? Hezekiah? Because here?
Yeah.
Because what the publisher did was they were multiplying this times that and this times that. And so it put this first because this was the number that was this was the character getting multiplied by everything else. But this is the same thing as that. It's the same thing. Okay? Good. We're doing well. Draw a line across your paper. Your classwork is on page 94, 25, 18, 16, 14, 11, 9, 7, 6, and 3. Remember, quite a few of these are supposed to be done extremely quickly. So you need to push yourself. You also need to try and do it without actually looking at your notes. You want to try and see if you can do it from memory. You need to push yourself.
Push.
All right, colored pens up. Remember, the classwork portion of our lessons is still the middle of the learning process. So I do not expect perfection at this point. So the idea is to learn from mistakes. So let's see how we did. Number 25.
Yes.
This was the Punnett square. This time you were asked to make it. It's up down there on the bottom. Then the polynomial, I mean, it ends up being the same as what we did together. And then the answer to part C ended up being the same as what we did together. That was kind of coincidental, but there was only two possible choices. And here we go. Now, for 18, I would accept that as negative 4y squared plus 25, or 25 minus 4y squared. Either way. Number 16, 16x squared minus 9. 14, 49p squared minus 4. Number 11, z squared minus 400. Number 9. It's a little bit tricky because of a couple of variables, but still the same idea. 9y squared minus 6xy plus x squared. Number 7, 100z squared minus 60z plus 9. And number 6, 49a squared minus 84a plus 36. And number 3, 25s squared plus 20s plus 4. Hezekiah and then Brandon. It's not to the power of 2. It's times 2. So you should not have left it that way. All the middle terms should be there. So, for example, in number 6, to get the middle term, 7a times negative 6 is negative 42a times 2. All you have to do is double it. So negative 42 times 2 is negative 84. So we get negative 84a. Okay? So that's a part of the confusion that you need to work out. Okay? So don't go home and make that same mistake. You got to figure it out before you walk out of my room. Okay? Brandon and then Anita. Yes, if you put it in the opposite order, that's fine.
And then, switch 76.
Okay? For which one are we talking about? Okay. Well, these are all square binomials, so that's what you're supposed to do. But then you're supposed to multiply the result times 2. To get the middle term? Okay, so you got confused. Okay? So all of the terms come from this. Okay, so you got to keep going back to this to get the next term. The first term is this square. The last term is this square. The middle term is these two multiplied together times 2. Okay? I understand what you're saying. Okay? So just try to work out that confusion before you walk out of the room so that when you go home, it'll make a little more sense. Okay? Any other comments, questions, or concerns? Okay? Draw a line across your paper. Your homework is on page 590, numbers 4 through 42 even. In preparation for your quiz on Tuesday, you're doing page 592, the ready to go on, numbers 1 through 9. It's a total of 29 questions, which is on the high side of my homework assignments. However, keep in mind a couple of things. One, half the questions you're supposed to do in about 2 seconds. And you have a long 3-day weekend to complete the assignment. Read the next section. Read the next section. And then you will have a quiz on Tuesday. And I already explained that you will have class on Tuesday. And it will be on 9.1 to 9.3. I usually don't like giving quizzes the next day after I did a lesson. I usually like to give you a couple of days to allow the lesson to digest. So what we're going to do is we're going to go over the homework first. We're going to make sure everyone feels comfortable, and then we're going to take the quiz. Okay?